Hey y'all, in this video we are going to go over the example from the projectile motion notes. In this example we have a ball being kicked horizontally off a 30-meter tall cliff at a velocity of 2.3 meters per second. So first let's just draw a picture to give you an idea of what's going on here. It never hurts to do this. So we have our cliff, we have our dude kicking the ball, and it's kicked initially horizontally, so it's going to end up falling to the ground like this. All right, so our first question is asking how much time it takes this to go. So before we do this, let's go ahead and make a chart of the information that we do know. So our acceleration for this, if we're not told otherwise, we know we're on planet Earth. And for all these problems, we're ignoring air resistance. So that means our horizontal acceleration is going to be 0 meters per second squared. And our vertical acceleration is going to be negative 9.8 meters per second squared. Then for our distance or displacement for each, we know that the cliff is 30 meters tall. So it's going to fall negative 30 meters because we assign this negative direction, or this downward direction to be negative. So we're going to make that 30 negative 30. Then for time, we don't know that we want to solve. And initial velocity, we know it's kicked horizontally at 2.3 meters per second, and that means all of that velocity is in that horizontal direction and there's no initial vertical velocity. So that's what we know so far. So now we can go back to number 1 and solve for time. So to do this, to figure out which formula to use and which column to use, you want to look at what you know more of. Normally time's one of the first questions you'll be asked in a series because it's a pretty important variable to find other stuff from. So looking at our table, we can see that we have 2 things in this horizontal column and 3 things in this vertical column. We want to use the column we know more in. In this case, we know more in the vertical column. And based on what we know here, our distance formula is going to be a great formula to use to solve for time. And we're going to use the vertical information to do this. So we're going to use our distance formula, and I'm going to put tiny y's in here, these are subscripts, to tell you that I am using the vertical column. So you know where I'm getting this information from. And I'm putting that y on everything but time, because time's going to be the same for both columns, because just as much as it takes it to go down, it takes it to go over. So I'm going to plug in everything I know. I know distance, or my displacement here is negative 30. My initial in the vertical is 0. So that's going to cancel this out. And then just leaving me with 1/2 times negative 9.8 times time squared. To simplify that, you're going to have negative 30 equals negative 4.9 times time squared. Divide that negative 4.9 over. That is going to give you 6.12 equals time squared. And then square root both sides. And you get time of 2.5 seconds. All right, so there's question 1. All right, so I'm going to go ahead and add that time to my table. So 2.5, and that's for both columns because, again, the same amount of time it takes it to fall to the ground is going to take it to go over. All right, let's move on to question 2 here. Question 2 asks us to find how far away from the cliff we're going to land. So how far away? This is the edge of the cliff. This is where the ball lands. We want to know this. We want to know horizontal distance. So for this, we want to use the x column because that's the horizontal column, and we're going to use the distance formula again, this time just with that column. So it's your horizontal distance equals your initial horizontal velocity times time plus 1/2 times acceleration in the horizontal times time squared. So we're going to solve for that horizontal distance, and that's going to equal your initial horizontal velocity of 2.3 times 2.5 seconds. And then the second half of this is going to be canceled out because that acceleration here is 0. So we don't need to do the second half of this. So you're going to multiply 2.3 times 2.5, and you get 5.75 meters for the horizontal distance. So then you can add that into your table if you would like. And that's the horizontal distance that it goes. So that's this right here. All right, for number 3, we are looking for the final velocity that the ball is hitting the ground at. So we're looking for what it is right before it hits the ground. So this ball, just drawing the end part again, is falling like this. We want to know this final velocity, the final velocity of the total ball, not just in the horizontal or not just in the vertical, the total thing. So for this, that VF is what we want. But to find that, we're actually going to do vectors. So you have your final velocity in the x direction, and then you have your, let me switch colors here, your final velocity in the y direction, but we want the overall final velocity. So to find that, we need to find the finals for the x and the y, and then use Pythagorean theorem. So to find your final velocity in the x is real easy. It's technically the third formula on our sheet is what you're using. But because our acceleration is 0 in the horizontal, that's canceled out. And that means your final velocity is equal to your initial velocity of 2.3 meters per second. So there's no actual math, but just to show you where I'm getting that from is that formula. Then you're going to use the same formula to find the final for the y. And this time you do have to technically do a little bit of math. And so your final velocity in the y, your initial is 0. So it's just going to be negative 9.8 for your acceleration times your time of 2.5 seconds. And you're going to multiply that, and you are going to get negative 24.5 meters per second. So you have now the VFX and VFY. We don't want that. We want VF. So you're going to now do Pythagorean theorem. So you're going to have 2.3 squared plus 24.5 squared. I'm making this positive because this negative is telling us which way it's going, and this arrow in the drawing is now telling us which way we're going. So this value is 24.5. And then that's going to equal our final velocity squared. So we're just going to solve Pythagorean theorem just like we did when we learned vectors. The left side here is going to equal into 605.54 equals VF squared. And then square root both sides, and you get 24.6 meters per second as your final velocity. And that's your answer for number 3. So let's now do the very last one, and that's to find the angle. So the angle you're looking for here is this angle here, and you did this already when we did vectors again. It's just going to be inverse tan your opposite side, or in this case VFY, over VFX, your adjacent side, and that's going to give the angle. Excuse me. And so you're going to have inverse tan of 24.5 over 2.3, and that equals your angle. And that value is going to equal 84.6 degrees. And that is it for number 4. So if you're still stuck on any of this, just let me know, and I will be happy to help.